Welcome back. Problem 12-12. So statement is determine the equation of elastic curve for the beam using x1 and x2 coordinates. Specify the slope at A and maximum displacement of beam. EI is constant. So you can see this is a simply supported beam with a point load at a distance of A from point A, which is P, and there is another point load of P at a distance of A from this end B. The total length of beam is L1. So you have to find the equation of elastic curve for coordinate x1, which is v1, and equation of elastic curve for coordinate x2, which is v2. And also you have to find the slope at A and maximum deflection. So due to this loading, the beam will deflect like this. So we have to find that. So let's start with the solution. So first step is that if you remove this support at point A, so you will be having a reaction force, let this is RA, and if you remove this roller support at point B, so you will be having a reaction force which is RB. So you can find this RA and RB by using equation of equilibrium. So first equation is that sum of all movement about point A is equal to 0 and taking the counterclockwise movement as positive. So about point A, one moment is due to P into perpendicular distance is A, and that is producing clockwise movement, so it will be negative. So I will write it minus P into A. The second moment is due to this load P, and perpendicular distance is this one, which is equal to L minus A, because this is A, this is L, so this distance will L minus A, and it is also producing clockwise, so it will be negative. So I will write it minus P into L minus A. The third moment that is produced due to this RB force, so RB and perpendicular distance is this L, and this is producing counterclockwise, so it will be positive. So I will write plus RB into L is equal to 0. So minus PA minus PL plus PA plus RB into L is equal to 0. So this will cut with this, so we will left with RB into L is equal to P into L. So from here you will get RB is equal to P. Clear? So we have RB. Now you can find RA by using another equation of equilibrium, that sum of all force along y direction is equal to 0 and upward force is taken as positive. So first force is RA, which is upward, so RA. The second force is minus P, third force is also minus P because they are downward, plus RB, which is plus P, is equal to 0. So this will cancel with this, and we will get RA is also equal to P. Now you have both RA and RB. So what we will do is that we know that equation of elastic curve can be found by using this equation, EI into d square V over dx square is equal to moment. So first we will cut the beam at a distance of x1 for coordinate x1. So for coordinate x1, if I cut the beam over there and draw the free body diagram, so beam will be like this. At point A we have RA, which is equal to P, this coordinate is x1, and when you cut the beam you will be having a shear force which is Vx1, and there is a moment which is also equal to mx1 due to coordinate x1, and let this point is O. So we are interested to find out the moment. So for that we will apply the equation of equilibrium, that sum of all moment about point O is equal to 0 and taking the counterclockwise moment as positive. So about this point O, one moment is P into x1 and it is producing clockwise, so it will be negative. The second moment is mx1, which is positive. Their sum must be equal to 0. So I will write minus P into x1 plus mx1 is equal to 0. So mx1 is equal to P into x1. Okay. So this is the moment equation of moment for coordinate x1. Now we will find the for coordinate x2. For coordinate x2, what we will do is that we will cut the beam over x2 and draw the free body diagram. So if I draw the free body diagram, so it will be like this. Here you have RA, which is P. This total distance is now x2, and here at a distance of A from this end, this is A, we have P. And when you cut the beam, you have a shear force which is Vx2, and there is a moment which is Mx2. So we'll find this Mx2 for coordinate x2, not x1, x2. So for that, I will apply sum of all equilibrium. Let this point is 0. So sum of all moment about 0 point is 0. Clear? So now you can see that one moment is P into this distance, which is x2, not x1. So make correction here as well. This is x2. So P into x2, which is minus the second moment is due to this load P, and perpendicular distance is this one. Now this distance is equal to x2 minus A. Okay, so x2 minus A, I will write it plus P into x2 minus A plus this moment which is Mx2 is equal to 0. So I will write minus P into x2 plus P into x2 minus P into A plus M of x2 is equal to 0. So this will cut with this, so we will left M of x2 is equal to PA. So this is the moment equation of moment for coordinate x2. Now what we will do is that we know that E into I d square V over dx square is equal to moment mx, or moment. So for coordinate x1, we have moment mx1, so you have to put it. So we will get EI into d square V1 over dx1 square is equal to m1 of x, and m1 of x is px1. Now integrate this equation once, integrate it, so you will get EI into dv1 over dx1 is equal to px1 square over 2 plus c1. Let this is your equation number 1. Now again integrate equation 1, so you will get EI into V1 is equal to px1 cube over 6 plus c1x1 plus c2. So this is equation number 2. Now what we will do is that we will, for coordinate x2, we will also find this. For x2, we have mx2 is equal to p into a. So EI into d square V2 over dx2 square is equal to m2, which is equal to PA. So integrate it once, you will get EI into dv2 over dx2 is equal to PA x2 plus C3. Okay, again let this is your equation number 3. So again integrate equation number 3, so you will get EI into V2 is equal to PA x2 square over 2 plus C3 x2 plus C4, and this is your equation number 4. Now here you can see C1, C2, C3 and C4 are unknown constant of integration. So this can be found by using boundary condition. So boundary condition, we will apply boundary conditions to find C1, C2, C3 and C4. So what are these boundary conditions? So first boundary condition is that at x1 is equal to 0, we have v1 is equal to 0. So let me show you. Now you can see that due to this loading, the beam will bend like this. Clear? It will bend like this. So here you can see at x1 is equal to 0, we have deflection v1 is equal to 0 because there is a pin support. So first we will use this boundary condition. Now you can see at x1 is equal to 0, v1 is equal to 0. Which equation we will use? We will use equation number 2 because that is about deflection of point due to x1. So put x1 is equal to 0, v1 is equal to 0 in equation number 2. So when you put x1 is equal to 0, this term will be 0, this term will be 0, and v1 is also 0. So it means that C2 is equal to 0. So we will get C2 is equal to 0. Now we will apply second equation for boundary condition. So what is that? So we will write at x2 is equal to L by 2. We have dv2 over dx2 is equal to 0, and we have also due to symmetry. I will show you in a while. So now you can see that here at the mid of this beam, where we have x2 is equal to L by 2 because x2 is varies from this goes to further to mid. Clear? So x2 L by 2, if you draw the tangent to this line curve, clear? So here theta will be is equal to dv2 over dx2 will be equal to 0 because slope of this line is 0. So dv2 over dx is equal to 0. So what we will put in equation number 3. Why? Because you can see that equation number 3 is dv2 over dx2. So when you put x, so ei from equation 3, I will write from equation 3, ei dv2 over dx2 is 0, so it will be 0. Concentrate on this equation. Pa into L is x2 is equal to L by 2 plus C3. So from here C3 will be equal to minus Pa into L divided by 2. So this is C3. Now third boundary condition is that at x1 is equal to x2. So if x1 and x2 are same, so it means that you are talking about this region. x1 is equal to x2. We have deflection dv1 over dx1 is equal to dv2 over dx2 because at this point you have slope is same for both. So at x1 is equal to dv1 over dx1 is equal to dv2 over dx2. So we will put in equation number 1 and equation number 3 and we will equate both. So I will show you. If I equate from equation 1 from equation 1. x1 is equal to x2 is equal to a. Okay, so this is your equation number 1. So if I put x1 is equal to a and dv1 over dx1 is equal to the same dv1, so we will get e into I dv1 over dx1 is equal to pa square over 2 plus c1. c1 is not known, so plus c1 is not available. Okay, so we will get this equation, and dv1 over dx1 will be equal to 1 over ei into pa square over 2 plus c1. We will get this. Now what we will do is that again you have to put, I will write a line over here, put x2 is equal to a dv2 over dx2 in equation 3. So this is equation number 3. So I will put it over here. So we will get ei into dv2 over dx2 is equal to pa square plus c3. And c3 is, what is the value of c3? c3 is this, minus pal over 2, minus pal over 2. So we will get dv2 over dx2 is equal to 1 over ei into pa square minus pal over 2. So now you have this dv1 over dx1 and this is dv2 over dx2. So you equate them. So dv1 over dx1 is equal to 1 over ei into pa square over 2 plus c1, and dv2 over dx2 is equal to 1 over ei into pa square minus pal divided by 2. Okay, let me copy this these two equations, and we will move to second page. Copy it and move to the second page. We paste here. So you can see 1 over ei into pa square over 2 plus c1 is equal to 1 over ei into pa square minus pal by 2. Ei is constant throughout, so it will cancel. So we will left pa square over 2 plus c1 is equal to pa square minus pal by 2. We are interested in c1, so it will be equal to p square over pa square minus pa square over 2 minus pal. So you will get c1 is LCM of these two. It will give you 2 pa square minus pal. Clear? And we will get pa square over 2 minus pal. This is equal to c1. Okay, this is equal to c1. Now we have c1. So what we will do is that we will apply the fourth boundary condition. So fourth boundary condition, what is that? So at x1 is equal to x2, we have v1 is equal to v2. So let me show you here. We have said x1 is equal to x2. So here you can see the deflection, which is v1, is equal to v2 as well. So what we will do is that we will put it in equation number 4 and equation number 2. So let me copy these equations so that you can easily understand. Over there, this is your equation number 2. I will copy it. We will move over here, we'll paste it. This is equation number 2, and I will copy the equation number 4 as well. This is equation number 4. Okay. Let me remove these extra things. Okay. Now if you put x1 in equation number 2 for equation 2, x1 is equal to x2 is equal to a, x1 is equal to a, we have v1. So put it, so we will get ei into v1 is equal to p, x1 will be replaced with a, so p a cube over 6 plus c1. C1 is, again you can see c1 is which we have calculated over here. Where is that? Okay, c1 is this one. So c1 into x, so c1 is pa square over 2 minus pal into x1. x1 is a. Clear? And c2 is 0, so therefore that will be 0. So from equation 2, when you put x1 in this equation, so you will get this. From equation, okay, so we will further simplify it. We will get v1 will be equal to pa cube over 6 plus pa square over 2 minus pal into a divided by 1 over ei is equal to v1. Now from equation number 4, when you put x2 is equal to a, here deflection v2 is v. So what we will get is that e into I, v2 is equal to pa a square, so pa cube will be pa cube over 2, clear? Pa cube over 2 plus c3. So c3 is again minus pal over 2 into x2, which is a. Let me show you c3. c3 is minus pal over 2. Okay. Plus c4. So c4 is again we do not have c4, so c4 will be there. And from here v2 is equal to 1 over ei into pa cube over 2 minus pa square l over 2 plus c4. Now at x1 is equal to x2 is equal to a, we have v1 is equal to v2. So this is v1 and this is v2. So equate them. v1 is equal to v2. So v1 is 1 over ei into pa cube over 6 plus pa square over 2 minus pal into a is equal to v2, which is 1 over ei into pa cube over 2 minus pa square l over 2 plus c4. So this will cut with this. So we will left with these terminologies. Clear? And when you solve this at the end, it's very easy now, you can do it. So you will get c4 will be equal to pa cube over 6. Okay. Now you have all the values c1, c2, c3 and c4. So first part is you have to find the equation of elastic curve for v1. Clear? So you have to find this, and that equation of elastic curve is this equation 2. This equation 2 is for v1. So you can put the value of c1 and c2 in this equation. So you will get, let me show you, you will get v1 is equal to 1 over ei into px1 cube over 6 plus c1. So c1 is what is the value of c1? C1 is this one. Clear? So c1 is minus this minus plus c1 is pa square over 2 minus pal into x1. Clear? Plus c2, which is 0. So this is your equation of elastic curve. So when you solve this, you multiply all these values and you solve it, make it further simple. So you will get v1 is equal to p over 6 ei into x1 cube plus a into 3a minus 3l into x1. So this is the equation of elastic curve for coordinate x1. Equation of elastic curve for coordinate x1. Now we will find the second part. Second part is equation of elastic curve for x2. So you have the equation v2, so you have to put all the values of c3 and c4, and at last when you put it, you will get v2 is equal to pa over 6 ei into 3x2 square minus 3lx2 plus a square. This is the equation of elastic curve for coordinate x2. So you have to put the value of c1 and c2 in equation number 4, c3 and c4 in equation number 4, and you have to simplify. So you will get v2. Now what we will do is that the third part was you have to find the slope at point A. So slope at point A means that slope at point A means that x1 is equal to 0. So you have to move to the equation number 1. This is equation number 1. You have to put c1 over here. Clear? So when you substitute c1 in this equation, so let me do it here. Over here we have dv1 over dx1 is equal to 1 over ei into px1 square over 2, and c1, the value of c1 is this one, pa square over 2 minus pal plus pa square over 2 minus pal. Clear? So this is dv1. So if you put x1 is equal to 0, so this term will be 0. Clear? And this will be also 0. So you will get dv1 you have to find the slope at x1 is equal to 0. So this term will be 0, and we will dv1 over dx1 will be equal to pa square over l. Okay, let me write it so that you should not confuse. So when you put c1, put c1 in equation number 1. So what is the equation number 1? So equation number 1 is ei into dv1 over dx1 is equal to p over 2 x1 square plus c1. So c1 is c1 was pa square over 2. c1 was plus pa square over 2 minus pal over 2. Clear? So at x1 is equal to 0, so this term will be 0. So we have dv1 over dx1 will be equal to 1 over ei. Clear? And we will left with pa square over 2 minus pal over 2. So we will take out 2 outside. x1 is equal to 0. Okay, so if you take pa as common from the upper side and 2 is from lower, so pa over 2ei, and we will left with a minus l. So this is dv1 over dx1 at x1 is equal to 0, which is equal to slope at point A. Clear? And you know that a is less than L, so it will be a negative value, so it means that slope is downward. So this is the answer of our third part. And the last part is that you have to find the maximum deflection, Vmax. So where will be Vmax? So Vmax will be maximum at x1 is equal to x2 is, not x1. x1 only limit to till A. So x2 is equal to L by 2. We have Vmax. V2 is equal to Vmax. So what we will do is that you can see that this is the equation of V2, equation of elastic curve for V2. So for x is equal to L by 2. Clear? So you have to put in this equation. So when you put x is equal to L by 2, you can just put it and simplify it. I will write only the answer. So when you put it in that equation, so V2 is equal, now will become equal to Vmax, and we will get Vmax is PA over 24 EI into 4A square minus 3L square. Clear? And with this Vmax will be equal to PA over 24 EI, and if we bring it to 3L square minus 4A square, so this value will be become negative, and if you want to remove this negative sign, so it will be EA over 24 EI. Since negative means downward, so it means that maximum deflection will be equal to, maximum deflection will be downward. And that is the answer of our fourth part. So this was all about problem 12-12. It's indeed it was a lengthy problem, but the easier one. You have to solve it by yourself, so that you should be confident about solving such type of problem. If you have any question, you can ask me in comment section. Those who are new to my channel, then subscribe it and press the bell icon so that you can get notification about my latest videos. Thank you for watching.